Hello. Okay, guys. This is, I think, the first live stream from me, and today I'm gonna solve some JE paper in latex. So I actually made this paper for the upcoming test, and now I wanna make solutions. So I thought let's get live as I solve these papers. So so let's get started. So this is the paper, but I want, as you can see, I have renote some command. As soon as I comment this out, you can see the answer as well. As you can see, we are getting the answer as well. So I want another command so that mm, I want to hide the solution of these like papers. Like I can share only the paper or only the solution or combined as well. So let's see how we can do this. So let's make a command, uh, or we can define some. Let's define first, then we can change anything. Let's say solution, and solution will accept one argument, and this will just for right now just say quad, and actually we have to just say has one. Let's run this. So as soon I run the solution and write something, so let's complete this one and let's see what happens with this. So as you can see, we are getting the solution, but not in the proper manner. So let's firstly test this one. So maybe I want to hide in the future, so let's check it out. So if I want to hide, I will just edit to quad or some random stuff which I don't want to see. So yeah, as you can see, as soon as I run this code, as you can see, a still solution exists in the document, but it is not render as the full document because we just replace whole this thing with a quad or singular space. Or even we can replace whole thing with nothing. It will be better, I think. So as you can see, previously there was a space in between the questions, but now it's nothing. So let's continue with, so let's put hashtag one, and as soon as we run this program, you can see the solution. Now we can modify here something like we can add the headline. So let's add, what do you want to say, um, let's say no, no, nothing for I want to put just put an arrow. I think that would be better. So right arrow, this is double right arrow, so that there will no problem. Yes, I think it's fine, but no, I don't think it's fine. I want solution to be in red. So what can I do? Let's say what if we change the color? So let's, for right now, text color, and text color should be red, and in that I can put, let's see what happens for red. Yes, so this is fine, I think. And Now we can add anything we want. So after arrow, we can put something like we should describe solution or just solve it out. I don't understand. What should I do? I think I don't know. We should write something. So let's say this, as you can see, this is a two-dimensional collision or oblique collision. Yes, two-dimensional collision, and and as you know, as you know, no, no, only the component of normal surface is non-zero. Yes. I think we should do some better. This is a two-dimensional collision, and as you know, only the component of the impulse along the normal to the surface is non-zero. So I think we should write other stuff as well or not. I don't know. I think we should keep it short. Oh, let's put this in a alignment environment. That will be much better, I think. Alignment. Now we can put arrow. Arrow will be post. I think. I don't know. What should I know? I don't know. I think intertext I can. Let's check is it working or not. Yes, it's working. So now we can add only momentum momentum of the ball will change, or the ball will change only in the x direction, or only in the normal, a long normal बोल सकता हूँ, along the normal which is x direction for here right now. So yeah, I think this will clear the idea. Under the ball will change only along the normal. So yeah, we did complete the solution. Yes. So let's move on to the second one, and again we can start solution. And we can initiate with the right arrow probably, and then we can begin aligned environment, and in between we can place the equation or in the text. So this is I think a cylinder, yes, homogeneous solid cylinder, and it's rolling on the surface. Yes, rolling without slipping, and we have to find the angular acceleration, that means alpha we have to find. So firstly I think we have to draw some diagram because should I draw or not, I don't know. Yes, I should draw because rolling in clockwise direction, and that means some force must be acting. So friction, let's say, so we have to again begin with the diagram. So let's say begin center, and within center we have to insert the text picture, and within that my throat is hard, I think. Let's copy this diagram, and we can add extra whenever we require. So for right now we don't need this picture which is the surface, but we need all this, and let's run it first. I think alignment, let's for right now just put F, and it will be okay for rendering purpose. No, something is wrong. So what's wrong? Let's say for right now, is it? No, there is a problem. I think text color is not working for the text picture. Yes, I can understand, and let's just hide, or we can change color later on. Still it's not working. What is the problem? Where is the problem? I don't know. No, it's not working. We have to check the log file or output. Int picture globally int has is group text picture. Yeah, it's fine. Where is the problem? Yes, this is the solution. Begin center, and no, nothing is fine. It's all God. But what is this problem? Let's delete first. Let's see what's going on. Oh yes, so it's working. That means we have to just draw the, oh, that means this must be fine. Text color which was red, and in that's right. Yeah, it's bugging. So yeah, here it's diagram. Now we have to indicate a friction force, which is TZ line, and which must be like that, and we have to make sure where is the center. So center is at O, and from center we have to move down. So O is the center, and from that we have to just shift radius, which is radius I think 1 unit. So 0 comma -1, and from there we can move -2 unit on 0, and if we want relative lining we have to just add addition with the digit line, and now we can put up the friction force, which is Fr. Yes, let's run this, and yeah, as you can see, we have to shift this level to the left, and it will be fine, I think. Yes, so this is the friction force, and forward direction we are seeing the force. And now we can apply the equation according to this diagram. So now begin alignment, aligned, and either we can apply torque due to friction. Yes, let's complete and run first. Let's see what Copilot is suggesting. And is it right? Torque due to friction about the center mass. Yes, it's right. Wow. Half and yes, it's horizontal, so that's why half mr square alpha, and alpha is equals to it now, and now friction force is equals to force applied. Why? I don't know why it will be such. I don't understand why it is making the point. Why friction will be equal to alpha? No, it's trying to apply some calculation, but I think it's wrong. And let's show the answer so that we can just fact check as soon as Copilot completes the solution here. So yes, so we can see that answer is right, but I don't think the logic behind the force and friction is right. So it's rolling, so we have to apply acceleration. So torque due to friction, yes, it's completely fine. Yes, it's completely fine. But second line is not fine. So from here we can say net force on the cylinder is F minus Fr, is F minus Fr, and here it is. We can add this equation. It's like F minus Fr is equals to ma, and if it's a rolling motion, then we can add alpha. I think P should it's not okay. I think it's not okay that yes, it's solving right, but actually it's not doing the what can say the perfect job. I want the equation of friction, which is for the torque as well as the net force, as the two separate equations, and just we have to add the equations and we will get the alpha directly. Just we can cancel out, and it's complicated. Why it's so complicating? Let's continue with this one. Let's continue with this one, and F minus Fr where it's putting Fr, that means we have to no, I don't know what's going on here. Let's for it now, just Fr is equals to mr alpha. Yes, it's fine, and but it's not elegant solution. I'm just not satisfying with it. And yeah, we can put the friction over there, we can get a still alpha, was not the elegant solution. Let's do it from the beginning. Let's don't follow this copilot thing. Should I? No. I think until here it's correct. From there we can fix. Yes, if r is equals to, yes, we can say that friction is like that, and then we can put this equation, diffraction O1 by 2, and then what is mr alpha, and we can just, yes, now we can get the alpha part. Yes, I think we got this one. Let's remove this part, or we can continue. Let's just continue, no problem. So as you can see, it's much better, and just we put the value of friction and we got the alpha, and it's correct. I think we can do much better job if we assume instantaneous axis of rotation. What if we apply the idea of instantaneous axis of rotation? That would be much better solution, I think. Much elegant solution. We can solve this in only few lines, 2-3 max. So pure rolling, and torque is equals to I alpha. That means we can find the torque. Yes. Let's put into another solution. So we can just say or part. So let's sampling now. Or how do I write or? Let's say a line, and we will figure it out. Text. No. Alternatively, yes. Right. Now मैं भूल गया. Yes, instantaneous acceleration. Instantaneous. IAR. Using IAR. Instantaneous acceleration. INS. Instantaneous acceleration. Yes. Quality is getting good, man. And so instantaneous axis of rotation, and we have to use another line. Yes, enter text. Let's yes, and then we can apply torque is equals to alpha. Torque tau is equals to I alpha. Yes, and torque will be force time. No friction. Simply F times R, and no, this time moment of inertia will be its cylinder. So 3/2 square alpha, and then we can find alpha. Yes, it's correct. Oh, no. Something is wrong. What's wrong? I think here. still wrong. This is the problem of latex. It doesn't provide proper like instruction where it's wrong. Just doesn't compile properly and does not give you any instruction. This is very frustrating. So let's see if it's wrong. Yes, line number 103, and I think yes, we've got the solution. Still something is wrong, but I think it's okay. Just a warning. So let's go up. So as you can see, this is the alternate solution using IAR, and as you can see, this is a much shorter solution. You can literally solve in a single line using instantaneous axis of rotation. So keep in mind, at least try to imagine once about IAR in the problem of rotation. It will be much shorter, I think, if possible. So here we just did is applied pure rolling motion. As you can see, if we think about this point, so about this point, it's in pure rolling, so we just found out the torque about this point, which is force times distance, and torque of the friction will be 0 because friction is passing from this point. And then after you can apply torque is equals to I alpha. So torque is equals to I. One more thing you have to take care is you have to take more difference about this point as well. So this will be 3 by 2 mr square, and then alpha, and we can find the alpha. I think it is delete this large part because that's boring. I don't like this long solution, this part. Let's give it that way. And let's check one more thing. What if we just replace or just remove this part? Is solution is hiding or not? So yeah, as you can see, it's working. Everything is fine. Solution is getting rid of. So let's complete and run this again. You will see the solution part. So yeah, we are getting solution in the same way. It's cool, man. And now it's time for another problem, which is 3. I think there is a system of 4 particles which have the masses m2, m3, m4, m, and have some acceleration of equal magnitude, but different direction, which is indicated in the figure. So let's continue. I think managing latex file is quite tedious. It's not proper suited for long documents. But anyway, there is no alternative for right now. Right arrow, yes, right arrow, and we have to draw. No, I don't think we have to draw any diagram. And let's complete this copilot solution and see what happens. Right arrow starts with yes backslash. It's a command, so let's run it again. Oh wow, it's great. But I don't think it's great because it's using position. Let's draw. Why center must be origin? It's wrong. Copilot often does some interesting thing, but it's just a auto completion thing. So don't believe on this Copilot thing. You have to check by yourself. So let's find out let's find out the acceleration of center of mass. Let the acceleration of center of mass so simply apply the equation equation of central mass. Apply the equation for acceleration 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 of central mass. Yes, and I think it's all wrong, so just we have to complete from the beginning. Yes, let's see what it provided. Yes, it's good. So I think it is getting on. You have to just replace text, and so that it will be much better. Yes, center mass. Yes, I think we should complete COM. That will be much better thing. And not just mass times x. Listen, I can put manually. That will be much better. Like a I cap, and I think minus a I cap will be the better, and 2m this time we had to replace which particle v, which is j cap. So a hat j cap, and particle c is going along the I cap, so this will be a I cap, a hat I cap, and particle d is going along minus j cap, so just we have to replace this part which is a or minus a j cap. Now we can run see what happens. So as you can see, minus a cap plus a j cap, and everything looks fine. So we can add properly. No, should I add? Yes, I think we can proceed. Let this complete this copilot thing. Yes, I think and there is a mistake here. It should be I cap minus j cap, not minus I cap minus j cap. So let's rerun it. Yeah, so it's fine. Let's move on to question number 4. I think Copilot doing pretty good because it is not trained for latex and doing some wonderful thing. So again, just have to put right arrow thing, and we can start. Should I draw some? No, I should not draw a diagram. It will be well understood by itself. A body is moving m1. Apply the equation of conservation of point of words, giving pretty good suggestions. Let me read the question because I have not. A body of mass m1 is moving with a known velocity v1 I cap, and it goes a collinear. Collision means one dimension collision, or you can say head on collision with a body of mass m2 moving with the velocity v2 I cap. After collision, m1 and m2 move with the velocity v3 I cap, v4 respectively. Still I cap m2 is 0.5 times m1 and v3 is 0.5 times v4. Then v1. I think it's pretty simple. It should be pretty straightforward. Yeah, let's run the Copilot thing and let's see what it's providing. I think, oh yes, there's a problem with line number. Let's rerun it again. Yes, so as you can see, it's just applying the linear momentum conservation, and I think it's doing pretty good. everything is positive, yes, it's all it. V1 must, no, oh, it's right, yes, just v4 minus v2, yes, it's right. And then v3 putting the value 0.5 v1 and m2 0.5 m1. Wow, is I mean, it's great. 0.5 times everything, 0.51, yes, before minus 2, yeah, it's great. Let's move on to 5. Solution. So question number 5, I think it's easy as well, because mass m is moving with velocity to v, and again we can use the conservation of linear momentum. Let's finish one second. Copilot is not suggesting anything. It's weird. Let's try again. Yes, it's suggesting. Again, you can see it is saying we should apply the conservation of linear momentum, but we have to be careful, because we will just apply the linear momentum along the x direction, not the y direction, because in the y direction there must be gravity or something. So we are not sure in which plane this collision is happening, but we should be careful, I think. So let's firstly run this Copilot suggestion, and let's see what happens. Wow, it's doing great. Just a minute. A particle of mass m is moving with velocity to v, collides with the mass 2 and moving with velocity v. So second part is right, but first part is wrong. It's mass times 2v, and now I think let's put c dot. This way you can just separate thing, nothing special, just separate the variable so that will feel good. Yes, to v moving in the same direction after collision. The first one stopped completely wide. Oh yes. I don't think it's already got the answer. It's not right. Yeah, it's explaining the idea right, but it's not applying the exact same equation as it needed. So let's see, after collision the first mass stopped, that means m should be stopped, while the second one splits into two. Yes, that means each mass will be, and both have the velocities. That means we have to just remove this part and add this cos 45 thing, 45 45 circle. Yeah, we should rewrite a command for the degree, but it's okay, I think. And then after what's happening now? Then after we can, I think, just put everything. I should add one more line for clarity, so that it will look fine, I think. Let's complete this 4 thing then. 4 MB is equals to 2 into square root of MB dash. Yes, it's right. And then after 4V upon 2 into square root of 2. Yes, it's all right. Yes, so 2 into 2 will get cancelled, but I think no, 2 upon the root 2 here 2 extra, so just we have to say square root of 2. Yeah, now it's right, because cos 45 will provide 1 upon root 2, and both will combine, which will provide 2 into 1 upon root 2, which will again output as root 2. So yeah, v dash will be 2 root 2 v. So yeah, it's fine. Let's move on to question number 6. Solution, and right, let's get some bottom. So yeah, it's question number 6, and again it's from collision. An alpha particle of mass m suffers one-dimensional elastic collision with a nucleus at rest known mass. It is scattered directly backwards, losing 64% of its kinetic energy. The mass of the nucleus is alpha particle of mass m suffers one elastic collision. Elastic, that means this would conserve the kinetic energy, right? And unknown mass, it is scattered directly backward, losing 64. That means I think we have to conserve the momentum here, that side, but basic do something more that will let's complete this first compile thing and run it. Oh wow, it's pretty wild. mv, yes, that's right, mv dash and mass times velocity raised at unknown mass. So why it's calculating v dash? Yes, half mv square and half mv square. Yes, it's right. Which is right, but I don't think it's doing the perfect job here. Because just missing the point. This is making it more complicated. It's not that complicated. It's very simple enough, but it is making much more complicated, I think. We should replace. No, it's making it more tough. Yeah, it's conceptually applying, right? Conceptually, it is the good idea, but calculation wise, just messed up. So let's delete everything below and let's run it, and we can see the clear picture, I think. So firstly, it's applying the conservation of momentum, yeah, it's right, and then it is applying the conservation of kinetic. Because it's saying 64%, then we can just use the idea of 64%, not we have to do every like kinetic energy thing. No, I don't have to do this. I don't know what to say. Let's delete all this crap and start from the beginning. Let's delete this as well. Leave the equation first, which will be like mass of the nucleus and capital V is the velocity of nucleus, and apply the equation of conservation of energy. Yes, it's right. But we have to say like 64 scattered back directly backwards, losing 64% of its initial. That means it has the remaining kinetic energy of 36%. So alpha particle, let's say alpha alpha particle Lewis kinetic energy means it has already yes wow, it's intelligent, that means half m v dash square no v dash square is equals to dot of yes it is let's run it first and see what we are getting applying the condition energy. Alpha particle loses 6 means it density scattering energy. And now we can cancel out half m completely, and we will get v dash. This is 6 by 10. Wow, remarkable. And now we can put this v dash thing into now one more thing. I think we have to add into text. No, I entered into text. Substitute no substitute not yet. The Nicholas got the 0. Nicholas got 6. Yes, worked it. And then we can half m vs square. Yes, 64. Wow. Wow. It's doing correct. Let's complete and move forward. So yeah, as you can see, it's suggesting capital M is equals to 64 by. No, it's wrong, man. How can you cancel this out? This is completely blunder. We have to find the square root, and it just messed up the whole thing. I think one more thing I have to do is that v dash is negative because it's moving backward. So let's say minus v dash and from here we want to solve for capital V, so that we can put the value of v dash and the capital V, and we will get the capital M. So we should get capital V, right arrow capital V is equals to 8 by 10 half cancel out over 8 by 10 times V, but at the same time we should get a square root of yes a square root of d frac capital M upon a small m is now it's fine. We can just put the value in momentum equation. I think this should not be that long. I am doing something wrong here. Yes, it's doing pretty good job. Let's run it first. Yes, it's doing right. Let's complete this. Let's run it. Now it became a square. Wow, it's completed. Yeah, I think it's okay, but I don't know, I'm not satisfied with this solution because it is too long. It should be shorter, much shorter. Let's keep it this way for right now, and I think later on this one. Let's move on to next one. I think we should make harder. Elastic collision 64. I think no, it's wrong. I think it's right, man. It should be longer. Let's move on to next one, which is 7. Where it's 7? Yeah, it's 7. So this is a form rectangular thin sheet, and some portion has been removed from the upper right corner, and just we have to find out the center of mass due to remaining portion. And also, as you can see, its origin is at point D, which is below left corner. So what should I do so that it will be shorter as well as I think we should run this first because most often than not it is giving the correct explanation. Center of mass of the shaded part, which it's wrong. It's totally messed up. So let's delete everything and start from the beginning. Center of mass of the shaded portion is the intersection of time. No man, no, that's not right. We should actually find out the center of mass for the complete rectangle. So let's center of mass of the, let's do it from the beginning. Center of mass of the rectangular set, complete rectangular set is at 2/2. I should be let's say let's call it vector form R, and let's see our center of mass text, center of mass for rectangular. Let's say rect. Let's call complete rect let's put it name ABCD, that will be much better. And this is equals to this. Let's run first. I think no, spelling mistakes is not been an issue. Oh yes, we missed a bracket here and we put it an extra bracket. Let's continue. No, very strong, man. Am I? I don't know what's it. It's right, very strong. I don't understand. I don't understand what's wrong. Oh, sorry. I put it in an extra dollar sign, which is wrong because we are in a land environment already. So yeah, it was wrong. No man, again it's wrong. Where? Let's read output. Line number 269, which says double subscript. Yes, so we can, yes, want this in another curly braces so that this will act like a single subscript, and within that it will nest the subscript. Yes, it's right. So our center of mass for ABCD is A by 2, B by 2, and now we can, I think, repeat the same part. Let's wait for complete center of mass. The shaded portion is at, yes, it's doing actually great. And HBGO, yeah, it's right. Let's run it first. So 1 by 4 times, no, it must be like A by 2 plus, it messed up everything. So it's right but not completely. So let's modify first. A by 2 plus A by 4, so like that. So let's remove this part, and what will be I'm confused. A by 4 plus A by 2, which is 3 A by 4, yes, 3 A by 4, and this will be 3 B by 4, and let's remove this A part, B part, and check it out. So yeah, it's fine, and and now we can I think apply the equation. No mass of the remaining portion is at complete mass of the remaining portion. So for that, we should apply basic idea. No, we should apply precisely. Let's say M remaining, text remaining, M remaining into, you can just see dot M remaining into V center of mass remaining. Yes, it's doing it. Let's run it first and see what's providing us. Minus yes, that's great. And now we can apply. So let's check it out. By mass remaining, oh, it's great. And then we can put the value, I think, and let's run it. I think let's change. Let's continue doing this, it's fun. No, it's busy. Oh man, we can from here on we should proceed manually. I think it's not a good idea. let's no, it's not a good idea to proceed like that. Let's defrag, and within defrag we should be putting mass, and let's say a by 2 I cap. That means again we have to apply defrag. Oh man, defrag is boring. I cap plus now it should just suggest defrag, but it's not suggesting. I think it needed an improvement. Copilot is good, but it's not suggesting the important part very often. You can say just try to complete the whole thing, which is wrong. I think most programmer want is like just you should complete the next word or next sentence of, not the full thing. And yes, it should do that, but it should just ask the permission for that, because that is, I think, more important. Yeah, it sometimes completes the whole paragraph, which is correct, but most of the time we just mess thing up. So I think until it does the great job, it should just stick with single line or few words at least, not the whole paragraph thing. So yeah, let's continue. So I want like m times complete mass, which is at its center mass a by 2 I cap, a by 2 j cap, and now we want to remove this portion. So sided portion has the mass m by 4, so we can just defrag m by 4, and then we can put where its center mass, yes, 3 by 4. So I think we should copy this whole part, and we can put this thing, but I should change 3 by 4. So 3 a by 4, and again 3 by 4, and in the denominator mass minus, I think, defrag m by 4, I think, and that let's run first, then we will see what's provided. Yes, I think it's pretty good, but one more thing I have to fix. We should use left of it, because left will just fix the length of the bracket. Left of right one of what I did. Oh yes, continue. So just fix this part, right, and we have to fix here as well, right. So yeah, as you can see, now it's okay, bracket wise. Now we can just, I think it's tedious to calculate all this, but this time I will take the suggestion. It will be alright, I think. No, it's not alright. Oh man, it's not alright. Let's fix. I think we should add. Let's add manually. So m. I've said is full form. Let's try to full form. No, this is not it. Latex expired. I have to log in. I don't want to add this flex. So let's try again. So we have to add a by 2 and 3 a by 16. So or should I? I'm confused. Why can't it? And let's see. Three. Here it's 3m by 4. So denominator is sorted out. Now we have to fix the numerator. So let's defrag and defrag. I think let's add I cap and it should be negative. So defrag hat j cap, and between that I think let's say for right now 16 is the, and both side it will be 16 and some part will be m, and actually I don't want to add. What's happening to me? Let's add on paper and to begin adding fraction. So a by 2 plus 3 by 16 is both has the common capital M. So let's add 16 will be the LCM to 8a plus 3a. That means 11a by 16. Yeah. No, it's not. Oh, it should be subtraction. That means 5a by 16 is. So m times 5 ma, yes, 5 ma by 16, and I think 5 mb. So this is a and this would be the b, and this is I think the right solution. So yeah, 5. Oh man. And now we can finally 5 by 12, 5 by 12, yes, this is right. So yeah, finally we got this, but it's not minus 88, it's oh I did the mistake, plus plus. So yes, 5 by I cap, that means coordinate should be 5 by 12 and 5 by 12. So we can finally write in the wow it's suggesting like greatest. Yes, as you can see, remaining 5. Wow, like for this job I think Copilot is great. Yes, it's great. And now we can move on to 8. I think 8 is pretty simple, but still have to solve. No man, solution needed. Let's get some water. Oh wow, it's finished. Let's run it and try. Torque, what is I don't know it is right or wrong, but seems right. Well, because no torque, and it's just applied torque Is it? I don't know. Is it right or wrong? Because it seems right, but I think it's wrong. No, 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 it's wrong. It's wrong. Half pi theta square, which is Bogdan. No, 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 half I theta square. I don't know what it is. Energy? Maybe energy, but derivative of energy. Yes, torque, but force is not the derivative of energy. Oh, let's do it from the fundamentals. Let's start from the equation of energy, which is rotational kinetic energy. So for rotational kinetic energy, for rotational kinetic energy, yes, that's right. And half I omega square is equal to k. Yeah, it's right. And let's complete this one and see what is getting. So yes, it's doing right, but I don't want omega. I think just we have to differentiate the word side. It will cancel some term, and this will solve the problem. No, diffract. This would complete, I think. Left. No, man. Let's run it. See what is providing. No, it's becar. Oh, I messed up. Messed up. Half I, let's say 2 omega or into alpha, because we just differentiate. So 2k theta. No. It should be. It should be diffrac 1 or 2, k will be common, 2 times theta and then omega. I'll just be differentiated the word. Let's put the intertext. Differentiate word. Oh wow, suggested very frequently. Let's put c dot, which will separate, and again here also put out c dot, which will separate the derivative and the constant term. And now we can find the alpha. I think alpha. Oh, but it just removed the k part. I think it's wrong. Half I omega square is the kinetic energy, which is k theta squared, and then we differentiated. Oh, sorry. Right side does not have. Oh man, I messed thing. So yeah, I should delete the whole thing and then start from the beginning, and it will, I think, suggest the right thing. No, let's put 2k I manually. So yeah, 2k times theta is the alpha. Yeah, it's correct. So let's move on to 9 number. This is the simple one. Just we have to apply the conservation of angular momentum. apply the conservation of angular momentum. uh, I don't think there needs expansion, but let's continue with the explanation first. So both the rings are initially at the center of the rod, and as the time passes, it just starts sliding towards the edge, and which will uh, which will create yes normal mg everything, but I think due to symmetricity the torque will get cancelled out and net external torque will still be zero, so we can conserve the angular momentum here for the system. So Copilot is giving some suggestion and let's complete and run it first. So yeah, applying the equation of conservation of angular momentum. Wow, it's great. I not momentum is a system. It is doing the right, but I don't think it does the great. Or does it? Let's firstly fix I not to I, which means initial, because to the right it just put it the F final, and now we can calculate. I don't think we need all this crap. We can apply simply. We can I not. So initially it has the moment difference here, which will be like d frac ml square upon 12. Square upon 12, and then omega naught, yes, omega naught, and let's see what Copilot has. ml square 12 plus 2m ml square. Wow, it's providing the right solution. Let's complete this first. Yes, so ml square will be the moment difference of the rod, but both the mass will move towards the right, so 2m ml square omega final, and then I think we can complete this part. Omega final. Let's just stop for a few minutes and I will be back after a while. So